Good morning, everyone. I hope you had a wonderful morning so far. Right, we want to finalize our topic on loci, and we looked at over the week, we are still looking at mechanisms, which is the last chapter in terms of the concept of loci. Right, so basically we are going to look at revision tasks, and we are going to focus on some past exam papers in terms of the questions that we are going to do today. This is about application. This is about consolidating our understanding on loci as well as mechanisms. So let's go for it and let's do it. I hope you enjoy this lesson and all the best. Remember, these very important statements from Rotary, right? I hear and I forget, I see and I remember, I do and I understand. It's about doing that would make you understand, right? So for practical subject, you need to do it in order to understand. That's our thrust, that's our focus, that's what we aim to achieve, doing and application. So let's go straight to our lesson and do it. Thank you. Right, a bit faint, but I think it's visible in terms of the question that we are looking at today. Right, it says, this is from 2016. It's a little bit old, but that's what we could find. Right, question 2, loci. Answer question 2, 1 and 2.2. Right, it's about mechanism. Right, given a schematic drawing of a mechanism consisting of crank OA, right, so we have got crank OA connecting rod AB from here to there, that's the connecting rod. Right, then we have got a swivel guide C that is guiding the movement of AB. So whatever you are going to do, the movement of AB is going to be guided by that point C. Then we have got the sliding rod DE, right? DE, which is from point D to point E, right? If it is said to be sliding, okay, I will explain that, which means it is basically moving to and from along a specific path, right? It could be a groove, it could be just a general path. Then we have got pin F. We have got pin F, which is here, right? And we have got horizontal groove GH. Like I said earlier on, we have got G to H, right? Where point E is going to slide, right? Move to and fro. All right, okay. So we have got G to H, right? So we are going to have that one is our groove. Then the next thing that we are looking at, we have got the position of center O on the drawing paper. Right, if we check here, we would have this center O, right? And the information that is here is going to be transferred to this part. Right, just so that we are able to see. Right, then the specifications are as follows. The positions of O, the positions of C, and the groove GH are fixed. So we are not going to change anything with regards to the position of point O, with regards to the position of point C, and with regards to the position of the groove GH. These are fixed, right? As much as the crank would move, right, we are not going to to change the positions of those points. Right, connecting rod AB is pin joint, crank OA. Right, connecting rod AB is pin joined. Right, when we are talking about pin joint, this point would allow AB to move freely, but it cannot be separated from O to A. Right, at point A, sliding rod DE is pin joined to connecting rod AB. Right, sliding DE is pin joined, which means there is an allowance of movement in terms of point D. Right, but it cannot be separated from AB, which is our connecting rod. Right, pin F is fixed to sliding rod DE. We have got pin F, which is this point. Right, it is fixed to sliding rod DE. So that position would not change. So whatever the movement of point E as well as point D, it would be the distance from D to F. Right, then we have got additional information. AB is equal to 120. A to B is equal to 120 millimeters. Then DE is also equal to 120 millimeters. Then AD, A to D is equal to 40. Then we have got DF, D to AD, which is that one. Then D to F is also 40. Right, and as you can see, O to A is equal to radius 60, right? Radius 30 since the diameter is 60. So from here to there, that's 30. So we want to copy this now, right? With the information that is given. So let's do the copying this side. Let me just position this so that we are able to see. Let me draw a faint horizontal line like that. Set my paper properly. Right, okay. That is the given circle. Then we need to find the position of point A. Just copying the information that is given. Right, for us to be able to find point C, we need to measure from here to there 45, then from here to the center line to that point 70. So I've already measured from here to there, that's 45. Then I need to measure from here to there 70. Right, that's point C. Right, we measure A, B is equal to 120. That's 120, that's point B. So we have got point B, right? We have got point C, like that. We can now outline this. Then we need point D, all right? We need point D. If we slide like this, we have got point D, right, which from A is 40 millimeters. So from here to there, it's 40 millimeters. Then we also need point E, right, at the end. So we need to measure 55 millimeters from the center, right? So 55, then draw a faint horizontal line. We are going to do that. We just extended this one slightly. Right. Then we measure from here to the 40. That's our point D. Then DE is 120. This is already 120, so we'll take this measurement. But stand at point D. Describe an arc. Like that. That is our point E. Right, we can now connect point E. Point D. We are satisfied, we can outline this. Then we measure from D to F. It's 40 again. Right, that's point F, that's the pin, like that. So we have got our information or apparatus in position. The next thing that we want to do, let's define the center lines. Then also define the groove GH. that's H, and that's G. Right. Then we look at the motion as crank OA rotates in a clockwise direction. Right, so the rotation has to be clockwise. You can indicate the rotation here like that. Right, so in a clockwise direction, that's a mark. You need to indicate that. Connecting rod AB freely slides through swivel guide C. Right, so AB passes through point C. Right, you find that in some cases we may show this one like this, just a plus sign like that. Okay, right, so AB, as this crank rotates, you find that this is supposed to move like that. Right, through swivel AB, swivel guide C, point E of sliding rod DE reciprocates along groove GH. So point E, it moves to and from, right? So we can do this. Right. So it shows that this can move to and from along GH. During the rotation, what are we supposed to do now? Draw to scale 1:1 the given schematic diagram of the mechanism. So this is what we have done. Trace the locus generated by point F for one complete revolution of crank OA. Show all construction lines. Right, so we have got this point F, which is here. All right, just maybe to make it easier and understandable, but I don't think we do have space. All right, we are also going to draw, even though it is not asked, just the part movement of point B, okay? Where we have got space, then we'll draw that in terms of the locus of point B. But the one that is required is point F, right, in terms of the locus. Right, just like we have been doing all along, right? In order to find the locus, you need to move the crank at intervals, right? And these intervals can be best described by dividing the circle into a number of equal parts. And in this case, we are going to divide into 12 equal parts. So we would say this is our point 0, right? Then we have got, because it is moving in a clockwise direction, this is 1, 2, 3, 4, 9, 10, and 11, and back to 0. So what we need is to move this point A to the next interval, which is point 1, and draw a line via point C. Okay, we do this. You can just label faintly, this is 1, right, so that you will be able to follow, okay? Right, then we go to 2, and you can also label just faintly, that's line number 2, it's important. Then we do this. Of course, if you can follow without doing that, it's perfectly fine. Right. That's 3. 4. 9. 6. 7. Eight. Nine. That's 10. That's 11. Okay. But once you have done that, you now take your canvas, right? Open your radius to AB, which is 120. Right. So you take this radius, right, from here to there, which is 120. Then you go to point number 1, right? You also cut line number 1 like that. Right, this point. That would be your B1. Then you cut number 2. That will be your B2. Number 3. Yeah. Then 4. Which is here. 5. B5. B6. B7. Eight. Nine. Let's take this one down a little bit. Right, we know this one is not required, maybe because of stress. That's B10. And last but not least, it's B11. Right. But let's suppose it was required. Okay, we said this is B4, and this is B3. Right, okay. Right, so we're going to connect this. Like that. Right, so that was going to be our connection. Let me just verify in terms of B4. B4 here, right? Then B5. Okay, so it's going to be here. So this one is slightly out. Right, as I said, this one is not required, but it's important that we just have an understanding of where the locus which is followed by point B. So you can now outline this. Like that. So that is the locus followed by point B, right? So we can also write here locus point B. Right, we know it's not part of the question, but I just wanted to highlight that sometimes you may be asked to find the locus of point B as well as the locus of point F. Remember, what is critical is once you have located point 1, point 2, point 3, point 4, point 5, point 6, and so forth, you then need to find or get A, D, then locate it on these lines which are going there. Right, so under normal circumstances, you would also, right, by default, just construct also the locus of point B. So now let's get back to what we are asked to do. That is to find the locus of point F. Right, okay, so we take the distance AD, take the distance AD, you stand at point 1, so this would be D1, right? I'm going to mark this, right? That's D1, that's D2, right? So what we have done basically, we have now also created the locus of point D, but for one complete revolution of Craig OA. So we can join this point, that's 11, that's point 0, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10, okay? We connect these points faintly. Right, we know that this is not required, but I just want you to give a picture to you as to how you can tackle this in terms of, right, in terms of local. Then we also connect from here. If you are satisfied, then you can outline this. So that's the locus of point D. Right, remember in an examination, right, if you are not asked to draw this, don't show it. If you are not asked to draw this locus, but of course for you to be able to find the locus of point F, you need these points. And these points would be on lines which are passing through point C, which is our swivel guide. Right, but for now, right, this is just for learning purposes. I've demonstrated this such that you would also realize that there is also a locus which has to be defined, right, in terms of movement of point B, which is linked to point F, which is also linked to point what? To point E. Right, but this is not part of the requirement. This is not part of the requirement, but certainly you would need these points in order to get point E, which would ultimately lead you to get point F. So we can also write here indicate with an arrow. Right, that's locus point D. That's locus point D. So we now have got the two loci, right, point for point D as well as point B, but we haven't answered the question which is required. The question requires us to find the locus generated by point F for one complete revolution. So for us to be able to find that, all right, we need first of all to take the distance D to E. Like this, take the distance D to E, stand on the new position of point D, all right? Then describe an arc like that. We realize now we have got, this is E1, then you stand at point D2, then we have got E2, right? You do the same up until you come back to point D. Then you come back to the original position. It's like that. The next thing is to join these points, right? D1 to E1. Which is here. Then we have got D2 to E2. So you will now have got connections from the locus of point D, right, to strike the groove GH. Right. Once you have done that, you now take again your compass. Right. You take the distance from D to F. Right. Stand at D1. Right. And cut like that. So now you have got D1 to F1. I'm going to label. Right. Then D2. Right, which is this one. F2, which is this point, and that point. All right, then 3. All right, which is that one, which is F3. Then 4. It's clear. F4. Then 5. It's here. F5. Then 6. You strike like that. Level F6. 7. That's F7. 8. F8. 9. F9. Then 10. This one. F10. Last but not least, it's 11, which is this one. So you write F11. Right. Remember, you are not obliged to show these labels here, but it will be ideal and also important to show someone, right, what you are doing and how you are doing it. So we then define these points nicely so that they are clear. Right, we have put that. That's 5. That's 3, 2, 1, 11, 10, 9, 8. Then we'll connect to these points. Right. If you are satisfied with what you have done, then you can as well outline this. Maybe let me just use, but this is clear. So that is the locus which is followed by point F, right? So as the crank OA moves in a clockwise direction like that, it's ultimately going to generate the locus of point D as well as the locus of point B on the other hand, but also generate the locus of point F. Say you want to provide a safety guard, right, around the movement of point F. Now you would know, right, I would need something that would close it like that. So it's important in the design of systems and machinery that one has to be able to define the full extent of a movement of each and every component so that you avoid accidents, you avoid parts colliding against each other, and you also make sure that your machine or system is safe to use. So that is the whole idea in terms of mechanisms. So it's a very important aspect of design as well as engineering. Right, I'm going to label this one now. So that's locus, point F. All right, okay. So this is it, right, for 20 marks. All right, you find that you were supposed to get 20 marks, right? Point the given information, just copying this information on its own, you would get 5 marks. Then the construction which is required, the division, the center lines and everything, right? You would find you would get another 12 marks. Then the locus itself that you are going to define at the end of your constructions would give you a further 8 marks. That according to the marking rubric, you find that you would get everything right if you follow the principles and the procedure that we have just shown. I hope you understood this one. But we want now to look at another example in terms of a past exam paper that would also enhance our understanding with regards to mechanism. So let's look at this. Let me take this one off. Right, this was part of paper 2 of a trial exam in one of the provinces, right, for 2019, right? So it's a past exam paper, but we know that the trial is an important part of assessment in terms of our matrix or our grade 12s. So they had a question like this. So we want to look at it and see how best we can come up with the answer that is required. So let's go straight to the question. Right, again, you'd find this one is question number 2. In some cases, you find that it will be combined with either right? The helix or the chem, right? And as you know, that the helix, the chem, and the mechanisms, they are all part of one big family of loci, which basically illustrates the importance of finding the locus of a point. Right. Answer question number 2. Answer question 2.1 and 2.2. Right. The first one is 2.1. Right. Given a schematic drawing of a mechanism consisting of crank AB. So we have what A to B. Right. That is the crank. Then connecting rod BC. We have what B to C. Right. Then connecting rod CD, we have got C to D, and crank DE. That's D to E, right? That is the crank. Right, so we have got two crank mechanisms, one at the top and one at the bottom. What are they supposed to do in terms of the motion? Right, during the motion, both crank AB and crank DE rotate in a clockwise direction and at the same speed or velocity. So you find that this would move in a clockwise direction like that. The speed of this one and the speed of that one, they are basically the same. Right, draw to scale 1:1 the given schematic drawing of the mechanism. Trace the locus generated by point C. Right, this is our point C for one complete rotation of the two cranes. Show all construction lines, right? The given information, in terms of the information that is given, just to copy what has been given, you would get 7 marks. Then the construction that are required thereof, you would also get 5 marks. The actual, right, locus of point C would only give you 7 marks. So it's important to copy the information properly, such that ultimately the answer that you would generate would reflect the information that has been given. So let's start here. A faint line. Yes. We are given this is diameter 100, which means radius 50. So I'm going to measure 50. Let me take this one down slightly. Then we are told that in terms of point A to point B, right, there is 30 degrees. So we are going to define the 30 degrees. So locate point B here. This is point A. Right, and the height from here to there, that's 146. Do we have enough? No. mark a point. Oh, it's out. Just take this one. Right, so from here to there, that's 46. Like that. And we draw a faint horizontal line. Take this one. Right, okay. Then it's offset slightly by 22 millimeters. So in terms of the center, get to the top. So we measure 22. Right, so that is our point E. Yeah. That is our point E, right? Point A, then offset by 22 millimeters, we have got point E, right? Then the next thing, the diameter of this crank is 60, so radius 30. There you go. Right, we need the position. Right, we need the position of point D, right, which is 60 millimeters or 60 degrees from here to there. So we're going to do this. Right, that's our point D, which is here. Okay. Then we are also told that the distance from B to C is 85. Right. Normally I would want to, it's 100, but which is also 100 here. I'm going to take this as my radius so that we locate point C. Take this one as my radius, stand at point B, describe an arc like that. Right. Then we have got 85, which is the distance from here to there, 85. Just mark 85. It's 85. Take this distance. Right, at point D, like that. Then we connect. Connect to here. So now we have got the system in position. Right, we've got A to B, we've got B to C. Right, so this is our point C. Right, then C to D, right, and D to E. We can outline this setup. Like that. There you go. So these are the given points with regards to our system in terms of the mechanism. Right, we are also told that the mechanism would move both, right, in terms of the two cranes, they would move in a clockwise direction, right? So we are going to define the direction, right? You can just show it here, right? And also do the same this side, show the direction there. That's also a mark, okay? Right. So what we need to do is to make sure that we can move point B at certain intervals. Remember, when we are talking about certain intervals, we divide in the circle into a number of equal parts. In this case, we are going to divide this into 12 as well as that into 12. So that when we talk about B1, we also talk about D1, both in clockwise direction. But before that, let's define the center lines. This is part of the given information, so don't leave this. You need them in terms of your constructions. Like that. So we have got the center lines in position. We do the same this side as well. Right. So now we have got the information that has been given. So just by copying this information that is given, you would find that you end up getting 7 marks. But we don't aim, or you shouldn't aim to get the minimum. You should aim to get the maximum. Right, we can divide the circles into 12 equal parts. Let's start with this one already. Right, we are going to say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and back to D, right, which is our point 0. Then this one also is point 1, 2, 3, 4, 5, 6, 7, right? You may not be able to see the bottom part, right? That's 8, 9, 10, 11, back to point B, which is our point 0, which is our point 0, okay? Right. So we need to have something like this in position. Right. So what you need to do, right, since the point C, right, it's a common point when you are starting from the big crank, which is A, B, as well as the smaller crank, which is E to D. Right, ideally you would need 2 compasses, right, one with radius 85 like that, then the other one with radius 100. So I'm going to extend this one. So that here we have got point C, right? If I stand here, right, like that, and describe an arc like this, right? Then go to one of this other one, take this canvas as well, then describe an arc like that. Now, what I have is point C1. So I'll label that one C1. Right. Do the same. Stand at point number 2, describe an arc like this. Right. You go to D2. Right, you mark. Just make sure you are using the right distance. So D2, you mark. You now have got C2, right? You describe an arc at point number 3, like this. You also go to point number 3. You cut that like this. You now have got C3. Right. So you do this process up until you reach or you come back to point C. So let me do that. We go to point D. Right. You take the other one, stand there. You cut. You have got points C4. Right, then 5, describe an arc. You also go to number 5. You cut the first one. And then you go to C5. You go to 6. Cut this one. Just check to verify. But when you feel the distance is shifted, you just adjust. It's fine. Then we go to 6, which is here. We go to C6. We go to 7. And you also go to 7 this side. Cut. Which is there. Then you go to C7. That's the point. That's the point. Point into the point there. Right. Okay. Just verify the 7. That's 8. You also go to 8. You cut it. C8. We do the same. C9. Right, so in terms of our locus, it's taking shape, like that. And then we go to 9, 10. We do the same, 10. Last but not least, it's 11. Describe an arc. We go to 11. We cut this. That's the 11. Okay. Right. So you have got this point. That's C, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, back to C. Right. Once you have done this, you take your canvas, your pencil, you connect these points. Right, you connect them nicely. You do the same this side. There you go. Right, so that is the path which is followed by point C, right, as crank AB as well as D to E revolve about point E and about point A respectively, right, in a clockwise direction. Right, if you have done that, if you are certain you've done the right thing, then you can as well outline this path. Take it from here. There you go. Right, so that is the locus of point C. Then you can come and label the locus point C. There you go. Right, so in terms of the concept of mechanism, right, what is critical? Make sure that you copy the given information properly. See how the crank would operate in terms of motion, right? In which direction, right? And how many divisions you require. Remember, you can come up with 6 divisions, you can come up with 8 divisions, you can come up with 12 divisions. But because you want to refine and make sure that your curve is good and smooth, but you don't want too much space between points. So the number of divisions, the more divisions you have, right, the better the quality of the curve as well. So looking at this, copy the given information properly, right, and establish all the construction detail that is required, and from there plot the locus, right, by taking note of points which are moving and points which are not moving, and you'll find that you'll get everything right. I hope you enjoyed this lesson, and especially this part of the lesson. Let me just check if we still have got enough time to look at another example in terms of our revision task. Right, I think we can accommodate one more task, but this one is taken from a certain workbook by HSC, right? We want to look at that. Look at that example. Right, so let me bring this one. Right, remember in an exam, right, you are not expected to spend more than 20 or so minutes on an exercise like this, right? Because you'll be doing a disfavor to other questions like question 4 and so forth. So make sure you are as fast as possible in terms of your speed, okay? But as much as you would want to be fast, make sure you are accurate and neat. Right, the mechanism consists of a crank or right? We have got the crank O to A, attached to a shaft which rotates clockwise at a constant speed about center O, right? So we have got the shaft, right? A detailed drawing of the mechanism, right? We have got, this is our detailed drawing of the mechanism. This is the line drawing of the mechanism. Right, a schematic diagram, that's what we refer to. The line diagram is referred to as the schematic diagram. Right, motion, rod AB attached to crank A, right? We have got crank A. Slides freely through a fixed point C. We have got a fixed point C, which is here. AB rotates freely about point A, okay? So you have got AB, right? Which is A to B, it rotates freely, right? You'll find that this part of the rod A to B, which is that shaft, right, it's able to go around like that, but it is pin joined at this point, so it cannot be detached from that point. So what is it that we are supposed to do? But with point O as a reference point, we've got point O here. Draw to a scale 1:1 the given schematic diagram of the mechanism, include all the labels, trace the locus of point D for the complete movement of the crank, trace the locus of point F, right? It's point E and point B, right? They made a mistake in terms of their labels there. So we have got E as well as B. All right, trace the locus of point E for the complete movement of the crankshaw or necessary constructions. Like I said, the most important thing that you start to, you copy the given information, but faintly. We have the diameter, right? OA is 40, so we measure this one. Right, then we draw. Take this one down slightly. Like that. All right, okay. Then we need the position of point A, right, which is 30 millimeters, 30 degrees rather. That's point A, right? We need the position of point C. From here, we need to measure 20 millimeters. Take this one down. Right, we need 90 millimeters from here. But instead of drawing the circle, we can just create a sign. This. Once we have done that, we can as well now get A to B, but from A to B, which is 160 millimeters. So we need 160. So we can measure directly from here. Right, so that we get our point B. This is our point E. That's O. Right, we have got point O, A, E, and B. We can outline this now. There you go. Find the center lines. Right, so we want the locus of point B as well as the locus of point E, all right? We may not need to complete this one together, all right? I'm just going to show you the direction so that on your own, you can then complete everything. All right, let's divide the circle into 12 equal parts. There is already one division, so I'm going to extend this. Right, then we are also told that the mechanism, right, rotates in a clockwise direction. So we can come here and just indicate on that. That is the direction, it's fine. You may stand here with a compass and define the direction as well. Right, now, if that is the case, then this would be point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, in terms of movement of point A. Right, so what it means basically, if point A is here, right, we need to draw a line from here via point E and extend it. Then afterwards, we measure A, B, which is 160 millimeters. So we can do that. Like that. So you can also, just to be smart, you can label this is point 1. Which would give us B1. That's 2. plus 3. That's 4. Then we go to 5. Five is basically in line with this, so we're not going to struggle. So 5. That's 6. That's 7. Just define this point. That's 8. That's a little bit. That's 9. Ten. That's 11. Okay. Then you can take, let's see. I'm trying to improvise with my canvas. Right, okay. Right. Then you go to point 1, line 1, like that. That is your B1. Then number 2, which is here. That's your B2. And 3, we need to extend this. That's B3. Also 4 needs to be extended. That's fine. That's B4. That's B5. That's B6. B7. B8. Just standing there. B9. B10. And last but not least, B11. B11. Right, so once we have gotten all these points, right? We have gotten these points, you can, this is B10, 11, connect them nicely. Right, so that is the locus of point B. Right, so then we can outline this. You can take a breather. You can also come from this end. There you go. Right, so that's our locus of point B. You can label this one. Locus point B. Right, so you are done with the first part, which is the locus of point B. The next one that you would require now is the locus of point E, right? Remember, there is point C. Okay, let me just correct this one. Right, I'll leave this one as it is, but we need to locate point C, okay? Right? This one was supposed to be point C, but point E would be somewhere there. Right, so A to E, it's 40 millimeters, which is now point C. Right, so we measure point C. Here we go. Then this is our point C. So we defined the locus of point B. The next thing that we want to do now is to find the locus of point C. Right. The process is basically the same. Right. You take your compass again. Right. This is the distance from A to C. Okay. Right. which formerly should have been point E, right? So we interchange that one, but it's not going to be a major issue, right? Then you mark here, that's C1. So it means to use this, that's C1. Then you go to point number 2. That's C2, which is that. You go to point number 3. That's C3. Do the same for 4. That's C4. 5. C5. 6. C6. 7. C9. C10. C11. Then back to C. Then you connect these points. We have got this, that one. All these points should be connected. So from here, to point C. There you go. Right, so if you are satisfied, you then outline the locus that has been produced. There you go. Right, so that is the locus of point. Just lift this so that you are able to see both curves. Come here, let's see. Locus point C. Right, so we have got locus point B and we have got locus point C. Right, so once you have done this, you would have answered both questions in terms of what is required. Looking at the given information, like I said, you copy the given information A0 to or O to A, then point B via point E, right? And we have got also a pin, which is point C, which is located on A, B. Right, first of all, shift the point of position of point A to the new position, then draw a line via point B, which is a guide. Then still, this AB does not change in terms of signs. You need to make sure that it stays the same. So from the new position, you take AB, AB, AB through the line which passes through point E, right? Then you end up having something like this. So these are the two loci, right? which are representative of the parts, which are followed by point C as well as point D. But I hope you have now understood this in terms of our topic on mechanisms. Right, so this is the end of our discussion on mechanisms. But when we meet, we now want to look at the concept of machine drawings. You know, it's a very important topic in paper 2, question number 4. So we want to look at that, but mainly we are going to focus on past exam papers. So for today, that's it. And enjoy the rest of your day, and goodbye.